Hi, my name is Will Anderson. Welcome to the MVPDays virtual conference, and today I'm going to be talking to you about desired state configuration in Azure. A little bit about myself. I am a cloud solutions architect at Cortex Services based out of Michigan. I am in the third year as a Microsoft MVP in Cloud and Data Center Management with a focus on PowerShell. And in 2015, I was lucky enough to be added as a honorary scripting guy. So before we move into the code, I just wanted to throw up a link to give you some of the materials that we're going to be working with today. I've given you some of the example code as well as a JSON template to deploy a basic environment into Azure, so you can go ahead and do a little bit of experimentation on your own after watching this video. Likewise, feel free to reach out to me on Twitter, LinkedIn, wherever you may find me. If you just type in Gamer Living Will, you can pretty much find me anywhere abouts on the internet. So to talk a little bit about Azure Desired State Configuration, what exactly does it give you? Well, first off, it allows you to bring the same level of configuration, standardization, and auditing that you normally have on premises into the cloud. It can be applied to existing environments as well as new implementations. So if you have environments that have been hanging out for a long time that aren't exactly up to your corporate standards, you can bring them into compliance with desired state configurations via Azure Automation, templates, and PowerShell, as well as bring your new environments into compliance. It also provides an additional level of security over the traditional pull server, and we'll be talking a little bit about that later. So let's talk a little bit about Azure Automation DSC and how it looks in the Azure portal. As you can see here, I have Azure Automation DSC nodes in front of me right now. These can be found in your Azure Automation account. So of course you need to create one of these before you get started. But one of the nice things that Azure Automation DSC gives you over traditional pull server is the ability to visually reference the DSC nodes, what their end state is at the given time, as well as what configuration is being applied to the machine. As we can see right now, we have a machine that's not in compliance. And if we review it, you can see here that as we start drilling down into the reporting, we can see that a Windows feature is not in the desired state. You can actually go ahead and drill down even further to get exactly what the Windows feature is and what the resource or the resource provider name is. So it kind of gives you an idea of what the portion of the configuration had failed and why it's in the state as it is. Right now we can see that it's just not in compliance. So you can see a new consistency is check is running. So it's going to be underway, and hopefully we'll get that machine in balance here soon. Looking at other machines, you can see that it's got a very rich history. You can go back and view whether or not a machine was in compliance or not, as well as see what configuration items are being applied. You can even drill down further and see what the dependencies are for the more complex configurations, and then see the further dependencies from there. And you can continue down the line until you can see at what point in the chain configuration had possibly failed. Reviewing the configurations, you can go ahead and take a look in here under DSC configurations and see all of the configurations that you've published to your Azure Automation account. Likewise, you can actually view the configuration code that you've put in your DSC config. But one of the things to note is that the generated moths, you don't actually have the ability to look at. So if we go over here to DSC node configurations, it might look a little bit redundant, but this actually gives you the configuration moths that are generated off of that DSC config file. However, if you see, I can click on it, but it won't actually allow me to take a look at the moth file that's been compiled as a result. This is one of the layers of security that you get with Azure Desired State Configuration, as the MOF file is encrypted up in the cloud, and not even the owner of the account can see the unencrypted MOF. This is to prevent configurations that have like user accounts or sensitive data from being exposed in any way. The MOF is actually sent to the DSC node, decrypted using its certificate at runtime to apply the configuration, and the local MOF in itself is also encrypted. And we'll take a look at what that looks like a little bit later. So let's take a look at how we can get some of those configurations up into Azure, compiled, and applied to our machines. The code that I'm going to show you is available on my GitHub repository at the link that I supplied earlier. So you'll be able to take the same code, download it, and do a little bit of playing on your own. I'm not going to bore you with some of the login stuff, so we're going to just go ahead and get right into it. After you've logged into your subscription, the first thing that you need to do is you need to get your automation account. You need to get the Azure, the resource group that the automation account resides in, and then the automation account itself. Once we've acquired this, we can go ahead and start putting together our modules and stuff. So what I've got here is a little bit of code to go ahead and do some compressing of the modules, put them into archives for us so we can go ahead and upload them. I've already done this ahead of time, so I'm going to get just straight on to how we actually get these up to Azure RM and import it into the modules directory, which I'll show you in a little bit. In order to be able to upload into the modules directory, we need to first upload the zipped files that we've created into a blob storage account. And then from there, we can import the zipped files into Azure Automation's modules directory. So once again, I'm going to go ahead and skip over the login, but we're going to go ahead and get the storage account where my modules blob resides. And then what we need to do is we need to get the Azure RM storage account key. Once we get that account key, as well as the storage account name and whatnot, we need to pass it over to the Azure SM commandlets for getting the Azure storage context, and then accessing the blob itself. This is because these commandlets don't yet exist in Azure RM. So we're going to go ahead and execute these. And now you can see that I've got the container that I want to go ahead and target. And after we've gone ahead and set our directory to the correct location, we'll go ahead and get these uploaded. As we upload to the blob storage, we're going to go ahead and also import it with the new Azure RM automation module commandlet. So we're going to do that for each and every single module that we're compressing and uploading. We'll go ahead and get a return here in a minute. And once it's completed, we can go back and check, and we'll start seeing that these are becoming available. Now that we've gone ahead and uploaded our zip files, we're going to go ahead and import that configuration that we were looking at previously. So I've got a nice little test configuration here that I'm going to go ahead and upload. And you can see that I'm casting a lot of things to variables as I'm executing these commands. And it's because that there's a lot of information in these that I'm going to have to be using a little bit later. And this is kind of a good example of some of that going on. You can see here that I've got the automation account name, the resource group name, stuff like that that gets used over and over. So it's a really good idea to cast a lot of this stuff to a variable so it can be reused later on. So I'm going to go ahead and execute this. This is going to go ahead and upload my configuration for me. And then once we've gone ahead and uploaded it, we can pass some parameters and config data over to it. So you can see here, I've got a little parameter file that defines what kind of domain, or what I want to call my domain, my resource group for the automation account, the automation account name itself. And this is because I'm actually leveraging the Azure Automation credentials inside of my configuration. So you can see here that I've already got a config, or already got a credential set up to be used in Azure Automation. So that way I can pass those credentials over to DSC and have it leverage them for while it's building the application. And here's some of my configuration data here. So I'm going to go ahead and create a config for a web server as well as a domain controller. And you can see that the node names, I'm not using localhost or any specific naming. I'm just telling it, I want web server as the web server, because I can actually use these configurations on any machine regardless of what the machine name is. When you build these configurations, they're all basically in the context of localhost. So it doesn't really matter what the node name is when you're building the config data. Although you do have to state what the node name is when you're building your config data. So we're going to go ahead and cast these. And then we're going to go ahead and compile our configuration. So you can see here I'm using start Azure RM automation DSC compilation job. Yes, I know the names get a little bit long here. Once again, I'm passing all of this information that from the commands that I previously executed here. And then I'm going to go ahead and execute this. It doesn't take long for the job to kick off and get compiled. If you want to check on the status, though, you can use the get Azure RM automation DSC compilation job command to take a look, or you can also go straight back to the configurations here and see what the status is. Now you can see that this one has gone ahead and completed, and then we can go ahead and see any outputs, errors, or warnings. One thing to note, that if you don't have the PS Desired State Configuration module, which is the default module for all Windows machines, called out explicitly in your configuration, you will get these warnings, but it's not that big of a deal. Now, we can also see that we've gone ahead and it's actually created generated three MOF files. It's created one for the domain controller, one for a SQL server, and one for a web server here. So now that we've compiled our configurations, we're going to go ahead and select our target VM. I just so happened to create a couple VMs before we started this, so we're going to go ahead and snag one of those by casting to variable here for the resource group and the VM itself. Once that's done, we're going to go ahead and add the PowerShell DSC VM extension. Now, you can check ahead of time to see if the extension is installed. For already existing machines, this is kind of important to do, because if the DSC extension is installed, you may get a failure when you're trying to register an Azure RM Automation DSC node. So you'll want to remove that extension and then reapply it. Here you'll see that I've actually got some parameters that I'm going to be passing through the register Azure RM Automation DSC node command for the local configuration manager. These are actually parameters that are available for that command, so you can actually configure, the configuration mode, reboot node if needed, as well as the number of times to check in. And that's going to be a little bit important when we start talking a little bit later about how the pricing model works as far as the on-prem and Azure machines go. So we're going to go ahead and cast our hash table and execute that register Azure RM Automation DSC node. Now, one thing to note is that this is going to hold your PowerShell session open until it returns a configuration success. The other thing that you may notice in the command is that I'm not actually applying a configuration when the node is registering, even though you can. The reason why is that sometimes you'll get a failure on the configuration apply. So I kind of split those out where I'm registering the automation node and then I apply the configuration. So that way I know that the registration is good, it's valid, it's waiting for a configuration, and then I can apply the configuration separately. So that way if there's a failure in one of the two, I can troubleshoot the exact one that it's failed on. While you're waiting, you can actually take a look and see what the status of the extension is. If you take a look at the virtual machine itself, underneath the extensions in the UI, you can see what the status of the extension is as it's installing. One of the things to note is that by default, it does install Windows Management Framework 5.1. So that's something to keep in mind if you have WMF requirements for certain applications. You can call out specific versions of Windows Management Framework if you require a lower version. You can take a look at what the detailed status is. It gives you a little bit of information as far as what the component status is, but it doesn't give you much more information than that. You can also use the get Azure RM VM DSC extension status command, but that requires that you open up a second session while you're waiting. Now that we've returned to success, you can get a little bit of information out of here, including some of the registration info, some of the parameters that were passed over to it, et cetera, et cetera. Once this is completed, we can go ahead and apply our configuration. So what we're going to do is we're first going to get that configuration from the Azure Automation account. Once again, you can see where we're kind of pulling a lot of this information from previously cast variables, as well as calling out the configuration name that we want to apply. So we're going to go ahead and execute this. And then we're going to go ahead and target the Azure Automation DSC node. This is where we have that VM info that we required a little bit earlier, and we're adding that to the mix. And then once we get the Azure target information, which I'll go ahead and show you right here, we're going to go ahead and pass this to, as well as the configuration information, to the set Azure RM Automation DSC node command. This passes over the target node ID, the configuration name, as well as the automation account name and resource group. So we're going to go ahead and execute on that. You can see that I'm running this in verbose mode. So now the node configuration has been applied. So how do we get the status? Well, we can get an Azure RM Automation DSC node report using that same information that we had cast earlier and take a look and see what the latest information is. Right now, it's not 100% registered, so it's going to return a null. But we can go ahead and take a look in here, go to our DSC nodes, and we'll see that target 02 is compliant because it's successfully installed the VM DSC extension. We can see a node configuration has been applied. However, there is no reporting as of yet because the machine hasn't received instructions to start downloading that configuration. It will do that on its next cycle in the next 15 minutes or so. A few minutes has gone by and we've run the get Azure RM Automation DSC node report again. You can see that the status is now in progress. Likewise, if we go ahead and take a look in our DSC nodes, we can see that the configuration is going from pending to in progress, and it's running its initial configuration right now. While that finishes baking, we can talk a little bit about how to get your on-prem machines into Azure Desired State Configuration. There's some example code that's been added to the GitHub repo that I've directed you to that you can kind of use in order to be able to explore this as a possibility. Now, you can either have the machines report directly into Azure Automation DSC using 443 TLS. It registers with public-private key auth to the DSC node, so it's over a secure connection. Or you can also use an on-prem Azure hybrid worker in a DMC environment to use that as kind of the machine for the registration and getting the marching orders to your on-prem machines. Some of the basic information that you can apply in the configuration are passed over in the parameters. So you need the registration URI of your Azure Automation account, as well as a registration key. You can apply a node configuration as an option. However, you can also leave this blank and just get the machine registered and apply a configuration later if you're more comfortable. As well, you can also configure other options for the DSC local configuration manager. Once this is done, you can execute this command here, and it will generate a localhost metamoth file for you. This is the exact same as a regular metamoth for a local configuration manager for a pull server. It's got the registration information as well as the configuration info for the applied config. Once this runs, the machine actually reports in relatively fast, and you can see that I've actually got my Surface Book configured with Azure Automation DSC. One of the differences between Azure machines and on-prem machines is that Azure machines are actually free to use Azure Desired State Configuration for, while there is a amount per compute hour that you have to pay for managing the on-prem devices. This is based on the number of times per day that you have it reporting in, and it can cost as little as 50 cents per month per node for on-prem machines to be monitored through here. So it's actually pretty cost effective when you start scaling it out to potentially thousands of machines in a data center environment. Likewise, you can also add Azure VMs direct through the UI by clicking on the Add Azure VM. This will actually look through the machines in your subscription. You can manually target it, and then click Connect, and then go ahead and assign those configurations here. So we're going to go ahead and do our test config domain controller. We can set the configuration, some of the LCM configuration options. So we're going to do an apply and autocorrect. I do highly recommend doing allow module override. So that way, if you need to update modules, it can get those updated modules to the machines. And then, of course, reboot note if needed is an option if you are okay with the configuration rebooting a machine. We go ahead and hit OK, and then that one's going to take a couple more minutes to go ahead and connect. So you can see here that the machine that we originally targeted is now showing in a not compliant status, and that's because it's run its initial configuration and found that the system is not in the desired state. So you can see here that we have our remove UI resource provider set up, and it's not in compliance. But now it's running a consistency check, and in a few minutes that should be coming up just fine. Now that a little bit more time has gone by, we can see that the consistency check is completed. It's run its course, and we are now in compliancy status. So now we can go ahead and log into the machine, and we'll see here that there's no desktop. We only have the UI here, or the PowerShell window and some of the UI management tools. I'm going to go ahead and open up the ISE because it's going to be a little bit easier for us to read some of the stuff here. So let me just zoom in real quick here, and then we're going to take a look at the DSC Local Configuration Manager. So we can see that the LCM state is, at idle, so it's no longer processing the configuration. It's going to go ahead and do that on its next cycle. But some of the things that you'll be able to see here is that with the configuration download managers, report managers, and resource module managers, it's all reporting to Azure Automation DSC. So if we do a get DSC local configuration manager, and we'll just go ahead and dive into that reports managers, we can go ahead and see the URI of the automation account and some of the source info, et cetera, et cetera. So we can now validate that the machine is in fact reporting to Azure. It is configured according to what our configuration said. But we can go ahead and also test the DSC configuration if we'd like. So we'll just do a detailed and get a verbose output here to see what it's checking. And we are in true status. So the machine is now fully configured. So one last thing that we can go ahead and check too is that you'll remember that I previously mentioned that the MOF is encrypted at compile on the Azure DSC automation account side. But how does it look when we're actually in the machine? Well, the MOF actually resides in System32 underneath the configuration folder as the current .mof. So we'll go ahead and take a look at that inside the ISC. And you'll see here that it's completely encrypted. So once again, the other advantage that you have to Azure Automation DSC as opposed to on-prem is that you have the MOF file that's encrypted at compile up in Azure Automation that's inaccessible to us. And when it gets down to the machine, when it's delivered there, it's also encrypted on that end. Really, the only thing that can decrypt the MOF is the DSC local configuration manager at runtime. So you get that end-to-end security plus the 443 TLS encrypted path. So you've got a secure connection going over there, or if you're going through the Azure Hybrid Worker, you further reduce the attack surface. So it gives you a lot of security, gives you a lot of flexibility, and it gives you a level of monitoring that you just don't get in the base pull server. So you have some very good dashboards. These are actually this information is actually accessible through REST API. You can also use Azure Runbooks to do some monitoring, trigger with watcher tasks to trigger actions if something goes out of compliance or if something falls off the deep end. So in closing, I do want to reiterate that on my GitHub repo under MVPDays 2017, I do have a lot of sample code. I have the code that I was walking through earlier as far as how to get the modules registered, how to get the MOF compile or the configuration uploaded, the MOF compiled, as well as sample configuration. It's my Surface Book configuration, so if you want to play around with that, feel free to go bonkers. And furthermore, I also do have a 4-part series on using Azure Desired State Configuration available on PowerShell.org, or you can go ahead and support myself and other authors through MVPDays by purchasing books like Master PowerShell Tricks Volume 2 and 3. Volume 3 just came out recently. So in closing, I just wanted to say that I hope you found this session enjoyable. I hope it gets you experimenting with Azure Desired State Configuration and that you had a good time watching. Thank you very much. My name's Will Anderson and hope to see you around sometime. Take care.